So next we are going to study about coordinate system. So in coordinate system we have three types of coordinate system. One is rectangular, spherical and cylindrical coordinate system. So here orthogonal vector components x, y, z. So here x, y, z. X, y, z means Cartesian coordinate or rectangular coordinate system. This is for orthogonal vector ax, ay, az. So distance between the vector means we have to take pq. From q we have to subtract rq minus rp. So we will get some x, y, z coordinates for q and p. So we have to subtract p from q. So for coordinate system, here we have rectangular or Cartesian coordinate system, cylindrical coordinate system, then spherical coordinate system. So for rectangular coordinate system, here we have x, y, z coordinates. So it may be call it as Cartesian coordinate system. So here rectangular coordinate system, the same thing. Differential volume element. Differential volume element means just to take x, y, z. This is for Cartesian or rectangular coordinate system. Just to multiply these three things, we will get volume. So this is for dx, dy and dz. Okay. If you want to get surface, you may multiply this x and y or y and z or z and x. If you multiply any two things, that is called differential surface element. If you take differential length means just take only one. It may be dx, either dx or dy. It may be dz. So any one you have to take it for a differential length. If surface xy, yz and zx. Likewise volume you have to multiply these three things dx, dy and dz. So vector expressions in rectangular coordinates b equal to bx ax, by ay, bz az. So b equal to bx square, by square, bz square. So a b equal to unit vector we are going to write for unit vector. Unit vector is defined as any vector divided by its magnitude. Just to take, if you take a b vector b, then b something is given like 2i plus 3j plus 4k means you have to take this vector whatever is given, then you have to take this coefficients 2 square plus 3 square plus 4 square in the place of bx, by, bz. So we will get in denominator 2 square plus 3 square plus 4 square root. Then we will get the answer for unit vector. So unit vector is defined as any vector divided by its magnitude. So here 2 minus 1, this is for x, y, z. Ax, ay, az is given. So its magnitude means just we have to take 2 square plus minus 2 square plus minus 1 square. So we will get 3. Okay, so unit vector, any vector divided by its magnitude. So this vector 2 minus 1 is given, magnitude is 3. So we have to write 2 by 3 ax minus 2 by 3 ay minus 1 by 3 az. Okay. So this is for unit vector. So next one is cylindrical coordinate system. So in cylindrical coordinate system, any point in space is considered to be at the intersection of three mutually perpendicular surfaces. So in cylindrical coordinate we will use rho pi z. So rho pi z for cylindrical coordinate system. So here we have to take instead of rho, in some books it may be written as r. So rho pi z or r pi z both are same for cylindrical coordinate system. So here we are having in cylindrical coordinate system rho pi z. Rho means 0 to infinity, pi 0 to 2 pi, z is minus infinity to infinity. So we can substitute these things in problems also for rho pi z cylindrical coordinate system. So a rho, a pi, a z, a rho square, a pi square, a z square for cylindrical coordinate system. So rho pi z equal to 1, rho pi z is at rho equal to 0. If you cross multiply this like a cross product, we will get rho pi then z, pi z then rho, z rho equal to pi. If same thing will be multiplied, then you will get 1. This for dot product, this for cross product. So keep in mind for cylindrical coordinate system. So here also we have differential volume element. So rho pi z we have to multiply this rho pi z d rho d pi dz. Extra we have only one term rho. Okay. So next one is transformation in cylindrical coordinate system. If x y z is given for Cartesian coordinate system, so we have to transform into cylindrical coordinate system. So rho pi z is equal to root of x square plus y square. Likewise pi is equal to tan inverse of y by x, z equal to z. This is for cylindrical coordinate system. Rho pi z is equal to x square y square, tan inverse of y by x is z. Likewise, if cylindrical coordinate system is given, then we have to calculate x, y, z. So x is equal to rho cos pi, y equal to rho sin pi, then z equal to z. Just we have to substitute the values for pi, rho pi z, then we will get x, y, z. So this is the equations. This is a table we have to refer for transformation from rectangular to coordinate, rectangular to cylindrical or cylindrical to rectangular, whatever it may be. So we have to use this table: ax, ay, az, a rho, a pi, az. So here we have cos pi minus sin pi 0, sin pi cos pi 0, 0, 0, 0. So we have to take this dot products. X into rho, x dot rho means cos pi, x dot pi is minus sin pi, x dot z is 0. So y dot rho is sin pi, y dot pi is cos pi, y dot z is 0. So z dot rho is 0, z dot pi is 0, z dot z also 0. So this is a dot product, we have to multiply these things, then we will get the answer. So transform the vector b equal to yax minus xay plus zaz into cylindrical coordinate system. For b rho, a rho. So we have to multiply with a rho. So here a rho, a pi. So a rho means just to multiply these things with a rho, then multiply these things with a pi. Then ax a rho, ay a rho, az also a rho. So likewise here a pi. Okay, then we have to substitute this x dot rho, x dot pi, x dot z in this equation. So we will get the answer for b rho, b pi, then bz. So we have to write b rho, b pi. So b rho we are getting 0, p pi we are getting minus rho. Likewise z also we will get, bz also we will get, everything is multiplied with z. So here az equal to 1 in dot product, so we will get z. So this is for b. Next we are going to study about spherical coordinate system. Any point in space is represented as the intersection of three surfaces. So for sphere of radius r from the origin, r theta pi. This is for spherical coordinate system. So first we have studied about rectangular coordinate system. In rectangular we have x, y, z. Then studied about cylindrical coordinate system, rho pi z or r pi z. Now third one is spherical. So here we will use r theta pi. So this is for spherical coordinate system. So r theta pi, r 0 to infinity, theta 0 to pi, pi is 0 to 2 pi. So this for spherical coordinate system, same thing. So here we have to write the vector a equal to ar, a theta, and a pi. So ar, a theta, a pi we have to take. So a equal to root of ar square, a theta square, a pi square. Ar square, a theta square, a pi square. So r theta and pi equal to 1. If you cross multiply these things, then we will get cross multiply these things, we will get 0. So this is for dot product. If you take cross product, r theta equal to pi, theta pi equal to r, pi r equal to theta. So in spherical coordinate system, r theta pi, r is equal to root of x square plus y square plus z square. This is from Cartesian coordinate system. So you have to transform this Cartesian coordinate system into spherical coordinate system, r theta pi. So we will get root of x square plus y square plus z square. Likewise, theta equal to cos inverse of z divided by root of x square plus y square plus z square. So pi is equal to tan inverse of y by x. So this is for spherical coordinate system. So point P has coordinate system here, r theta pi. If you convert this spherical coordinate system into Cartesian coordinate system, we will get x, y, z is equal to x is equal to r sin theta cos pi, r sin theta sin pi, z is equal to r cos theta. Okay, so this is for transformation from Cartesian coordinate system into spherical coordinate system. So we will get r theta pi. So this is for spherical coordinate system into Cartesian coordinate system. So this is also for x, y, z. So next one is differential volume. Differential volume means just multiply these things for r theta pi. So we have to multiply r theta pi, then we will get volume element. If you multiply r theta pi, r pi, we will get surface. So here for differential volume, we have to take r square sin theta, dr d theta d pi. Normally we will take dr d theta d pi. Here we have to take r sin theta. Just to refer this r sin theta, r sin theta. So we will get r square sin theta, dr d theta d pi. So this is the table we have to refer for dot product for xr, x theta, x pi. So this is for rectangular or Cartesian coordinate system. So this is for spherical coordinate system. So in spherical coordinate system, we will have ar, a theta and a pi. In Cartesian coordinate system, we will use ax, ay, az. So if you multiply this x and r, ax, ar, so ax, ar, we will get sin theta cos pi. Likewise, x and theta we will get cos theta cos pi, and x and pi we will get minus sin pi. So likewise, y are sin theta sin pi, y theta cos theta sin pi, y and pi cos pi. A z ar cos theta, a z a theta minus sin theta, a z a pi equal to 0. So this is for transformation from a rectangular coordinate to spherical coordinate, or transformation from spherical coordinate to rectangular coordinate. So both are same, we can use for conversion or transformation. So here we have g is equal to x z by y ax. So x z by y ax is given. If you refer x y z coordinate system, we will get Cartesian or rectangular coordinate system. So we are going to transform it into spherical coordinate system. Spherical means we will get r theta pi. So just we have to multiply this g by ar, then multiply this equation by a theta, then multiply with a pi. So xy divided by xz by y ax. Just multiply with ar, we will get ax ar. So we have to refer this table for ax ar. So ax ar, what we will get? Sin theta cos phi. Now we are going to substitute here sin theta cos phi. So we have to take this equation g dot ar. So for g we have written xz by y ax dot ar. So for x and ar we have referred this table, then we got sin theta cos phi we have written here. So now we have to substitute this x, y, z values from this equation. Just we are going to substitute this x, y, z in this equation. We will get r sin theta cos square pi by sin pi. Likewise we are going to calculate for g theta, g a theta. So g is given xz by y ax dot a theta. Now we are going to refer this table for ax and a theta. Ax and a theta we will get cos theta cos phi. So now we are going to substitute this cos theta cos phi in this equation. So we will get r cos square theta cos square pi by sin pi. So we have to refer this x, y, z in this equation. For x is equal to r sin theta cos pi, y equal to r sin theta sin pi, z is equal to r cos theta is given. So we have to write this equations in the problem. We will get g theta is equal to g dot a theta. So answer is r cos square theta cos square pi divided by sin pi. So next one is g pi. So here we are going to multiply with a pi. The same procedure like before we have calculated for r and theta. So x and pi. So we have to refer this table for ax and a pi. We will get minus sin pi. So minus sin pi, substitute over here, we will get minus r cos theta cos phi. Now we have to write all the answers in one equation, that is called g. So now we are getting a spherical coordinate system. G is equal to whatever g r, g theta, g pi, we have to write it over here. So r sin theta cos pi cos square pi by sin pi into ar. Likewise here a theta and a pi. So just write the answer for spherical coordinate system, r theta and pi we will get. So this for differential element in rectangular coordinate system. Rectangular coordinate system I have already said we are using x, y, z. So we can write dx, dy, dz in this equation for differential volume. If you take any one element like x, y or x, y, y, z or zx, then we have to write differential surface or differential area. Then differential length or displacement means just we will take ax dx, ay dy and az dz. So dv is scalar. So this is for differential elements in rectangular coordinate system. Then cylindrical coordinate system, here we are going to use rho pi z. So here we will use rho d pi dz. There only one term rho. So you have to keep in mind for cylindrical coordinate system we will get rho d pi dz. Then for spherical coordinate system, r square sin theta dr d theta d pi. This is for spherical coordinate system. As I already said, we have to multiply these things, then we will get the answer. The next one is called line integral. Line integral means just we will take any integral that is to be evaluated along a line. A line indicates a path along a curve in space. So we have to take vector A. So for this A, we will take A dot dl. So A dot dl means A is a vector. It may be A dot A or F. So A dot dl. So line integral around a closed curve is called closed line integral. So here we have to take A dot dl. So this is for line integral. The next one is surface integral. For surface integral we will get A dot ds. So A dot ds means we have written closed surface integral A dot ds equal to psi. So this is for surface integral. So here we have written ds. Then volume integral, just we have to take volume integral with dv. This is for volume integral. So surface integral, volume integral and line integral we have to take.